Fish reported. So testing is officially started today. It's open and available for you to take your test, but you have until Friday, just like the other 2 tests have been. So anyway, I just today was going to work through the test 3 review assignment on my math lab. I've skipped a couple of problems, but that's because you know, like long division, there's 2 of them, so I'm just going to work 1 of them for time's sake. But I thought this might help. Before I get started, if there's any of you that have any just question you wanted to ask before I get into working all this, you're welcome to do it. You can speak up, or I'm also open the chat if you want to do that. If not, I'm just going to share my screen and start working some of the problems. All right. Let's see. So it takes me just a second to get my screen going. So just one sec. Oh, hold on. It's acting weird. Hold on. Okay. It's acting weird. Hold on. Please let it work. There. Everybody can see it. Good. I did an update yesterday and then didn't check it. So got me a little nervous there. Okay, real quick. Before we start, let me pull up my participants. Like I said, right now, there might be some people who are just joining because I just sent out that text. There's about 8 of you right now, so please feel free to, when we're working something and I just start talking, please feel free to interrupt and just ask a question, okay? If there's anything that's not making sense, I really want you to say, you know, hey, now what, can you explain that again? Or something like that, all right? Okay. So let's just start going through it. The test, as I wrote in the email last night, has, I think, 19 problems. The review assignment has, I think, 22 maybe, I'm not sure. A little more, but this is the best way to study for your tests. All right, so we'll start with long division, if y'all are good. All righty. So with long division, we'll just start working through them, okay? So we are working through dividing. I'll try to be neat. I tend to not be super neat on this. Okay, so when you're dividing, remember, if you do skip a place, like we skipped the x value, you do need to put a 0 in that place when you're doing division. Same thing here. If you notice, there's no x cubed. So put a 0. If you forget to do this, you will not get very far before things start messing up on you, and it'll be hard to solve it. So, all right, we're ready to go. So remember to start, you just look at the first 2 terms. That's all you do. And you ask yourself, what do I need to multiply x squared by to get x to the 4th? That would be x squared, right? Okay, and then you have to multiply x squared by each item. So that's x to the 4th, x squared times 0, and x squared times 2. Okay, and now we have to subtract. So remember on subtracting, especially if you're writing down, make sure you understand when you subtract, that's the same as changing the sign of each term, and then you can just add them. So we get x to the 4th minus x to the 4th is 0. 0 and 0 is 0. And then 7 plus negative 2 is 5x squared. All right, so that's good. So now we can bring the 6x. We're almost done. 6x. Okay, and let's start over again. X squared and 5x squared. We just need a 5. Right? And the same thing like before, multiply 5 by everything. We get 5x squared, 5 times 0, and then 5 times 2 is 10, which means we have this extra place, which means we could have brought the 26 down there. if you need it. One more step and we're done. Subtract by change every sign and then add. So we get 0, 6x, and 16. All right. Okay, this is my remainder, 6x plus 16. So the way they're going to want you to write it right here, okay? The quotient, which is x squared plus 5, bring this up, and you'll say plus 6x plus 16 divided by what you divided by. That's how they want you to type in the answer. So the first one is the quotient, and then they want you to put the remainder over the divisor. So that's how they'll ask you to write it. If any of these long division ones, they're going to ask you to write it this way. Okay. All right. Everybody good? So I'm just going to keep going to the next one. Unless you have a question, just speak up. All right. Well, I welcome it. Okay, I skipped the second one on the review because it was another long division. You'll only have one on the test. There's 2 on the review, so make sure you know how to do both of those. Okay, this is the one with synthetic division, and it's going to come in the form of asking you about the zeros. So basically, if you remember, if they tell you that 1 is a 0, that means that we can divide. And I'm going to use synthetic. Remember, take out my coefficients. 1. Okay, and you use the 1 over on this left side is the 0. So use that 0. And then synthetically divide. And because 1 is a 0, you better get 0, right, for the remainder, or you've done something wrong. So let's start it. Let's bring the 1 down to get started, right? And then you're going to multiply and add all the way down. So 1 times 1 gives you 1. Then you add 3 times, remember you're always multiplying by this 1. So 3 times 1 is 3. Then you add. Then lastly, 2 times 1, and you add. And there you go. This is the remainder, right? Which is 0, which is because it was a 0, right? And then this right there is my quotient. So let's put the x's back in. You have 1x squared plus 3x plus 2. And so you basically divided it, and this is what we got for my quotient. So all you have to do to find the remaining zeros is just factor this and find the zeros. So that would be, and it ought to factor pretty easily for you. I mean, all the problems I've worked have not been anything too big. So, and it factors, remember the zeros, you set each one equal to 0 and solve. So I get x equals -2. Sorry, that's messy. -2. And same thing for this one, that would give you -1, right? So the remaining zeros are -2 and -1, right? Just a note, if you included the original 0 in the answer, so if you had listed 1 also, Pearson's going to count it off. I would go back and give you full credit for it. But if you're just aware of it, they're only asking for the remaining. That'll save, me some time. Okay. Just the remaining. All right. And so that's how it works. Okay. Good. Okay. So now we get to these asymptote questions. I want to make sure we go through them. There's 3 of these on the assignment, and I think, don't quote me on this because I need to go back and look, but I think there's maybe 3 of these on the test. So for those people who completely overlook the asymptotes, it really could hurt them on the test because you don't want to miss all of these. So let's go through each one, and it basically shows you for the horizontal asymptotes, it gives you all 3 possibilities that could happen. So it's a good review. Okay, so for this one, they're going to ask you vertical first and then horizontal. So for vertical asymptote, let me rewrite it because it's kind of small on my iPad. To find the vertical asymptote, you always want to make sure that it's simplified first. So you want to check, right, and see if it factors, and you can have anything that crosses out. So we have This actually does factor right there, and the bottom factors 2 minus 3. So it factors, but the factors can't be crossed out, so you really can't do anything to simplify. If there had been x plus 3 over x plus 3, you would have crossed those out and then worked the problem. But you can't cross this out, okay? So this is actually simplified. So to find the vertical, you just take the denominator, find where it equals 0, there, set it equal to 0 and solve. And these are your two vertical asymptotes. You have two, okay? Very important when you write your answer, please include the x equals. If you just put 3 and -2, you'll get it wrong because the asymptote is an equation of a line, so you have to have the x equals in it. So x equals. That makes sense? So please, please, please don't just put 3 and -2. X equals 3, x equals -2. So that's the vertical. And that's kind of how you work that one every time, okay? So now you get to the horizontal. All right, horizontal. Okay, so remember with the horizontal, as long as you know what you're looking for, you can answer this thing in a few seconds. Okay, so I'm going to recopy it again. Here's my function. Okay, so for horizontal, all you do is you look at the leading terms. And when I mean leading terms, it's the ones with the highest power, the x with the largest degree. So if it were out of order, I don't think that'll happen on the test, but if it were out of order, you choose the largest exponent. Okay, and what you do is you just compare the exponents. Okay, and there are 3 things that can happen. So they can either be the same, which this is not this case. So like if you had x squared over x squared, they would have been the same. This one is when the power is largest in the denominator, right? So that it's larger, and that can be like, it could have been x to the 7th. Okay, it's just, if it's larger in the denominator, very simple, it's y equals 0. Always. That's your horizontal asymptote. That happens every time when you have a larger degree in the denominator. Okay, so as long as you're looking for it, you can answer it pretty quickly. So let's see, A would be my answer, and you'd write y equals 0. Okay, very important. You got to have the y equals. It's easy. All right, does that make sense? Now we're going to do 2 more examples that's going to show you the other 2 possibilities for the horizontal asymptote. But this is the first one, when the degree is larger in the denominator, right? It goes to 0. Okay, here's another one. Kind of same thing. Vertical asymptote is only the denominator. There. Okay, numerator has nothing to do with the vertical asymptote, just the denominator. Set it equal to 0 and solve. That's it. X equals 1. Okay, nice and simple. So x equals 1. Okay, and now let's do horizontal. All right, once again, write it bigger. You just look at the leading terms, which would be right there. Okay, look at those 2. If you notice, the degrees are both the same. They're x to the 1st power. So when that happens, your horizontal asymptote is just the coefficients in front. 4 over, see that's a 1, 4 over 1, whatever's in front. So you could just write it as y equals 4. So it's just your coefficients. All right, so once again, you would have worked it the same way. If that had been 4x squared over x squared, you still would have gotten 4 over 1. So that's your horizontal asymptote, y equals 4. All right. I think if you put 4 over 1, they'll count off, which is frustrating. I would go back and give you credit for it, but just know if you have 4 over 1, they really prefer you to put just 4. Okay, and simplify. All right. Okay, and the final one, this is one is important because this is when you actually have to do a slant asymptote. So let's do this one. The first one for vertical asymptote. This is kind of the same. Like always factor if you can. This actually can factor, but I don't think it helps us again. This actually does. Yeah, see, it factors, but nothing crosses out. So it really doesn't help at all, but it's always good to check. So your vertical asymptote is just right there. X. So x equals -1. Vertical asymptote. So all of those have kind of been the same so far. All right, so that's pretty easy. Hey, I've seen people in the past also set the numerator equal and like list, do numerator and get 3 different ones. Just please make yourself a note because you will have notes, right, that you can use. Vertical asymptote is only what makes the denominator 0, not the numerator. Okay, so for horizontal asymptote. All right, let's see. I'm going to recopy. So if you look at the leading terms here, right, it's 2 and 1. Okay, so this is that third thing that could happen. What happens when the exponent is larger in the numerator on the top? If that happens, there is no horizontal asymptote. None. Okay, there is none. All right, but there is a slant asymptote, and slant asymptote only happens when the degree differs by 1. So when it's 1 larger on the top than the bottom, there is a slant. So because it was 2 over 1 or squared over the first power, there's a slant. If this had been x cubed over x squared, you still would have had a slant. It just has to differ by 1, right? So to find the slant, this requires just a little bit of work. You're going to actually divide the denominator into the numerator, make a fraction. You could use synthetic in this case, but I'm using long division. All right, it's pretty short, and your answer is going to be the quotient. All right, so x, all right, goes into 3x squared, 3x times. So let's multiply it out. All right, and then let's subtract. So change my signs. 8 minus 2. One more. X goes into -8x, and that just is -8. Okay? Now, you definitely could multiply it out and get the remainder, but for slant asymptotes, the remainder has nothing to do with it. This is your slant asymptote, the quotient, and it's always in the form of mx plus b. So, because it's a line, right? So your slant asymptote would be y equals mx plus b, which is a slanted line because it has a slope of 3. So once again, all you do is divide the denominator into the numerator, right? The bottom into the top, and the quotient's your answer. And that's your slant. So on your test, you would have picked B, and you would have gotten, there's no horizontal asymptote, but the slant, and you just type it in. And there you go. All right. So 3 of those, I know I spent a lot of time on that, but there's more than one of these problems on the test. So you just don't want to overlook the asymptotes. And as long as you know what you're doing, you can answer them really quickly. It's just for the people that kind of overlook it, it ends up hurting them. So everybody okay with the asymptotes, hopefully? So then we get to these polynomial inequalities. This was just kind of thrown in somewhere. We felt like we needed to cover it, especially if you're going on to take calculus, because sometimes you do have to use these the sign charts. So we did want to cover that, and we just needed to throw it in somewhere. So we threw it in here in the middle of stuff. So let's work these. You'll definitely see a polynomial one, and then you'll see one that's a fraction, a rational. So we'll do all this. All right, so let's look at this one. First things first, before you solve it, you want to get less than or equal to 0 on one side. So subtract 64 to the other side and set it up like that. You want 0. And then factor. So you just got to get it in factored form. And this is the difference of two squares. Right? 8 and 8. And this. Okay, so you get in that form. So now you just want to find, oh, I did it again. This is a 0. Sorry, I did that earlier. There's no reason there should have been a 1 there. Okay, 0. And then if you factor x plus, you set it equal to 0, you get x equals -8. Same thing here, x equals 8. So you solve it. You're basically solving this for what happens when it equals 0. And you get two answers, 8 and -8. Okay? These are also called the boundary points. Boundary. And basically, these are the points they're going to make up our intervals in our answer. So let's come over here. All right, we're going to plot -8 and 8. Okay? When I work this, I do lines to separate the intervals. I think on some of the videos I gave you, he used open and closed dots, but they're the same thing. So for mine, I'm going to draw my lines. Now I'm drawing straight lines because I'm looking for less than or equal to, right? The straight lines mean I'm equal to 0. 8 and -8 are the two values that equal 0. So those are going to be included in the solution. The lines are strictly there to tell me to include it in the solution, okay? If this had simply been less than 0 but not equal to, you would have done dotted lines, okay? That's the difference. If you see it on some of the videos, maybe he put like closed dots instead. They mean the same thing, okay? So either one is perfectly fine. All right, I like the lines because it gives me 3 clear intervals. So now we're going to test our region. Test each region, and remember, this is what we're plugging it into. Let's say x minus 8. So pick a number. Well, the easiest one, right in the middle, I can pick 0. It doesn't matter what order that you test it. If I plug in 0, I get 0 plus 8 is 8 times 0 minus 8. So I have positive times a negative number is negative. So that whole interval is negative. And then you do the same thing over for each one. Something less than -8, like -10. -10. If you plug it in, you get -10 plus 8, -2, and -10 minus 8, negative. So two negatives multiplied together give you positive. All right, and then the same thing over here. If you did positive 10, you would get positive and positive. Two positives give you positive. All right, so that's your sign chart. Okay, just a little hint here. When you don't have to know this, but just to kind of let you know, if you notice they alternate, positive, negative, positive, they don't always alternate. Sometimes you could have like negative, negative, positive. But if you have, when you have it, your factored form right here, if it's just individual factors that are to the first power, it alternates, okay? Now, if I had thrown in like a squared or something, that messes things up. Sometimes you have, they're back-to-back negatives. But this has, everything's first powers, so you do know it alternates, okay? But you might want to check just to make sure. Anyway, needless to say, the sign chart's kind of important. Now let's find our answer. We're looking for where's this less than or equal to 0. Less than 0 are numbers that are negative, right? So negative is my interval that's less than 0. So my answer goes from right here, the x's, from -8 to 8. And I would write it -8 to 8. The straight lines mean bracket. And once again, the brackets are there because I'm looking for less than or equal to. All right? Okay, so that's kind of how you work those. So The next two are very similar, but we'll go through them just to make sure, because in the past, these are the problems that a lot of people kind of have the hardest time with. So I want to make sure we do it. Is everybody okay with that? Making sense? Okay. Maybe if not, this one is very, very similar, but let's do it anyway because we have the time. All right, so we have, this is nice because it's already factored for us. Right? It happens to be set less than or equal to 0 again. You very well could have been asked for greater than, but okay, it's already factored. So set each one equal to 0 and solve to get your boundary points. X equals. So these are my boundary points, right? And that's what we're going to plot right here. -3/5 and 0. Okay, so then you have to decide straight or dotted lines. And once again, because it's less than or equal to, that means straight. Once again, I'm not going to count off if you don't put straight lines, but when you get to your answer, you better have brackets, okay? And the straight lines tell me to put brackets. So, okay, let's test a thing again. I'm going to recopy. This is what I'm plugging into. Okay, so let's start over here. Something less than -3/5. So we could pick like -1 or -2. If you plug it in, you get, for x, you get -2. And then 5 times -2, I'm plugging in right here. 5 times -2 is -10 plus 3 is still negative. Right? So negative times negative is positive. Right? Over here, if you pick something, this is a little bit harder because there's not a whole number, but anything smaller than -3/5, you could do like -1/5 or -2/5. If you plug it in, you get, for x, you get -1/5. And then if you plug in 5 times -1/5 is -1 plus 3, positive. So negative times positive, negative. And then finally, if we pick 2, you get positive and positive. Remember, I just told you, if you have two factors to the first power, which they are, x to the first and 5x, they're both to the first power, you know they alternate. So it went positive, negative, positive. Okay? It could have gone negative, positive, negative. So, it's not completely that order, but it does alternate. All right? So our final answer, we're looking for less than, right? Less than, which is just like the last time, less than. So my answer goes from -3/5 to 0. Straight lines are brackets. And there's my answer. So that one and the last one, very, very, very similar. The only one is the last one you had to, bring over to one side and factor. Okay, so those are your polynomial ones. If you notice, they're not anything too bad. Like, they're not huge with a lot of different factors and stuff. So probably that's how it'll look on your test. So, okay, let's do the rational. Okay, I really wanted to cover it. If you notice, it's probably the most basic one you could get, which is good. But it's one that people miss, and it all comes down to the dotted and straight lines. Okay, so I want to go over it again. So for this one, so to find your boundary points, all right, your boundary points are what makes the top and the bottom 0. So I'm just going to scribble this. If I set the top equal to 0, right, I would get -6, is that right? And the bottom, I would get 4. So those are my two boundary points. Hope that makes sense. I'm just kind of doing it in my head. This is what you're going to plot, right, on your number line, -6 and 4. All right. Okay. That's just kind of like the other ones too, except it's just top and bottom. And the only thing different is you're going to be dividing instead of multiplying, but it's the same rules. This is the only thing that's different, and this is what everybody misses. Okay, if you're going to miss, this is what you miss. Okay, it's the dotted and straight lines. So I'm looking for less than or equal to 0. So most people say, let's do straight lines. okay? But the denominator, the one that makes the denominator 0, never, ever, ever is a straight line. It is always dotted. So if you are making notes to help you on your test, please put that down. Always dotted for the one that makes the denominator, okay? So my 4 is dotted, okay? The reason we do that, okay, is if I were to take 4, plug it back into this function, I would get 4 plus 6 and 4 minus 4. I would get 10 over 0. Okay, 10 over 0 does not make sense. It is undefined. It's not a number, right? And 4 is what made it that way. So 4 can never be a part of the solution, and that is because it's the denominator. Now the top, the -6, you can plug that in. If you plug -6 in, you'd get what? -6 plus 6, -6 minus 4. You would have gotten 0 over -10. Okay, that is the number 0. Okay, so remember, if the top of a fraction is 0, that's 0. If the denominator is 0, it's undefined. So that's why one of them's dotted, one of them's straight. Okay, the -6 is straight for the same reason all the other ones were straight, because I was looking for less than or equal to 0. It's just, please make that note. The one that made the denominator 0 is never straight. Does that make sense? I'm just saying there's too many people that make this mistake. Put straight and straight, and then they put brackets in their answer and you get it wrong. So this only happens when you're dealing with the one that has the denominator, right? It's a fraction one, a rational. And then everything else from there, it works the same way, but just get your dotted and straight lines correct. All right? Okay, let's just test it really quickly. Let me rewrite it, figure it out. Okay, the middle one's easy. Let's plug in 0. All right, we get 0 plus 6 is 6. And 0 minus 4 is -4. So positive over negative is negative. Let's see, we'll pick like -10. -10 plus 6 is negative. -10 minus 4 is negative. 2 negatives divided still gives you positive. Right? That's negative. And then this one, it should alternate once again because both of them are to the first degree. If I picked 5, I'd get plus and plus. Positive, negative, positive. So my answer, because what am I looking for? Where is it less than or equal to 0, which is a negative number? Right there. So this is my interval. So my answer, final answer, I go from -6 to 4. Straight line means bracket. Dotted line means parenthesis. Does that make sense? I hope y'all, so please write this down because you're going to see one of these on the test, okay? And I want you to get it right, okay? Just make sure you have the dotted and the bracket and the parenthesis. All right? I hope that makes sense. I know I've spent a lot of time on that, but expect to see one of each, one that's the fraction and one that's the polynomial. So use your sign chart. Everybody okay with that? Okay? Hopefully. Okay, that was all from the first week. Now the rest of the test is from what we did this past week, which were logs and exponentials. So this is probably a little more fresh on your mind. Okay, if they ask you to evaluate the log without a calculator, now remember, you're not allowed a scientific or graphing calculator, which has a log button. So we can't do a whole lot, right? So there is this little shortcut method I talked about that you can actually evaluate a log. And so let me show you both ways here. The shortcut method here, if they say without a calculator, you can do this. Now 27 is 3 cubed, okay? And this is a little shortcut property. If you have the log base 3 of 3, which you have the same bases, then whatever's in this exponent is what it equals. This one just randomly happens to be all 3s, okay? But you could have had log base 3 of 3 squared, and the answer would have been 2, right? Something like that. That's a shortcut way. It's helpful, especially on this test, if you can recognize that. But let me show you the other way you can look at it without the calculator, if you like this better. So they want you to evaluate this. So what you can do is set it equal to x and then solve for x. It's just a basic little log equation to solve. And when you solve a log equation, you just have to convert to exponential form really quickly. Now remember how we convert. You start with the 3, the base, and you do this little counterclockwise circle. So you get 3 to the x equals 27. And you convert it. And now you have just a little basic exponential that you could solve it that way. 3 to the x, 3. Since the 3's are the same, then I can assume x equals 3. Okay, we went over both of these ways in class, and both of them are ways to solve it. Neither is more correct. You just might prefer to do one over the other, and that's perfectly fine. But I personally think for these, if you can do the shortcut, then great, right? Okay. All right, so here's another one. Oh, sorry. Right below it, we can do it both ways again. If you want to do it the shortcut way, look, anytime you see like a square root or a cube root, you want to write it as to a power. So that would be the same as 3 to the 1/2. See? So since the 3 and 3 are the same, it only can happen when your bases are the same. 3's, your answer, 1/2. It's a great little shortcut method, right? And if you did it the other way, you certainly could do it this way. Set it equal to x and say 3 to the x equals that, which would be 3 to the x equals 3 to the 1/2. So 3 equals 3, therefore x is 1/2. It's 2 problems right in a row that are kind of work the same way. Okay, they're just showing you a little shortcut method. Okay, so those are the logs. Let's see. The first section we had with this, we're going to actually do it a little bit later on equations. So I think the next one, okay, is all the expanding and condensing. This was section 5.3. Okay, so for these, they're not asking you to solve anything. All they're doing is they want you to expand and use those rules. Okay, so I wanted to give you this one. Look, if you get to this, I would simply approach it this way. If you notice, you have 1 over 256 right, times x, okay? Before you work it, I would go ahead and multiply those together, right, and get, so if you multiply those together, you would get x over 256. Go ahead and do that first. That will make working the problem shorter and simpler, okay? So if you can multiply those together, okay? I promise it just makes it, you don't have to, but it just, you can work it quicker. All right, so from here, all they want you to do is expand it. So we know from the rules that if you expanded, you have log base 4 of x, and since you were dividing the terms, you subtract between the 2 logs. Right? So the fact that they're being divided, it translates into subtracting between 2 individual logs. Okay? And so once again, because I had multiplied it together first, I could do this pretty quickly. So I would suggest doing it that way. Okay, they want you to take it a step further. Notice they say wherever possible, evaluate the log expressions. There's nothing you can do with log base 4 of x. I mean, that's nothing you can do, okay? But over here, when you have log base 4 of 256, please look for this. This is what we were just talking about with the shortcut method. I mean, you don't have a graphing calculator to type it in, but if you can write it in terms of the same base, now you wouldn't look at 256 and immediately think, oh, that's 4 to the 4th, okay? But I'm telling you to look for that, okay? where 256 is probably 4 to some power, because since the bases are the same, this whole thing simplifies to 4. So this is what they're wanting you to put, right? You expanded it, and it turns out that that second one could be simplified into a number. And they're wanting you to use the shortcuts, because all we're kind of talking about in this section were the little shortcut ways. So they just infuse this into a problem. Okay, if you didn't do that, you would get partial credit. They'd probably count the whole thing off, and I'd go back and give you partial credit, but you wouldn't get full credit if you stopped up here on that second step. So please look for that. And once again, all they're looking for is expanded. Okay, and that's what they want. All right, I'm gonna move on to the next one. The next one's not as to me, that's the most complicated one. This one, it looks kind of big. They're just wanting you to expand. So all they're saying is, okay, what do we have? We have a to the 6th b cubed over c to the 8th. And so to expand it into individual logs, you would say that's the log a to the 6th. Remember, plus, because they're being multiplied, and then subtract off. Or you can kind of look at it this way. The values that are in the denominator, you subtract them off, and the values that are in the numerator, you add between them. Okay, so I kind of remember it that way. Right? And so you've expanded it, but they do want you to take it one step further by taking these powers down in front. Remember, you can do that because it's a log. So you can say that's 620 over c. That is all they're asking for. They just want it in expanded form, just to show that you know the rules. All right, so there's 2 of those. I don't know, I can't remember. There could be 2 of these on the test. I'm just not sure. You'll definitely be asked to expand. Okay, so there's that one. That's all you could do. And now the next 2 go the other way. So it's just they reverse the order. All right, so this one, they want you to rewrite in a single log. So look, hopefully if you've seen this on the homework and if you worked it on the review, you can kind of recognize when you get to this problem, it's worked the same every time. Now remember what I was saying, when you have subtraction, that means, and you're combining it into one log, you're gonna put the term in the denominator. Addition means it's in the numerator, okay? So when I do this, I have log base 7. Okay, I have, sorry, it's kind of messy. Yeah. Okay, minus the log of x squared minus 4. So I'm going to divide it, right, because I was subtracting. And then notice the plus, I'm adding, right? Adding means put it up in the numerator. Let's see. All right. Okay, this is where some people get mixed up. And I know I mentioned this if you watched any of the homework I worked out. The only reason you would have put, multiply the x plus 2 times the bottom, I would have had to group it in order for x plus 2 to be in the denominator. Okay, so just remember, plus means you put it up in the top. Subtraction is the denominator. Okay, now from here, these ought to factor and cross out. Okay, they should work that way. So let's factor it. You get, let's see. Let's factor, let's see. Not factored. The bottom is difference of 2 squared. Right. So the good part about this review assignment is since the problems are similar in format, if you get to one like this, it might be different numbers, but it should be very similar to this. So that's why it's nice to take good notes. You can cross out common things, which is great. So your final answer would be log base 7 of x minus 5. And that's my answer. All right. Just don't forget to put the log in the front. A lot of people do all the work but carelessly forget to include the log. Okay, you have to have the log. You're combining it into one log. All right, so that's one that when you're combining, and there's one more that you're going to condense into one log. Okay, it's very similar to the problem we just worked, just backwards. Good, okay. And this one is just going condensed into one log, okay? So first things first, before, and we have it in terms of natural log, before you can condense them, let's get rid of the numbers in front. And we know the rule says that you can put that 2 back up top on the 3. Okay, you're just going backwards. So that would be there. Okay, you're putting it back up. Because you don't want to combine them into one until you just have natural logs. You don't want the numbers in front. Okay, but once you do this, remember, do not forget the natural log. I can't tell you how many I graded last year where they got the right term, but they just carelessly forgot to put the natural log in there. So natural log, this would be x squared, right, times, right, because of the plus, they're up in the numerator, and then the subtraction means you divide. And there you go. And I don't know, you typing it in, you might want to check. They might want you to put parentheses around it, but it's all the natural log. Okay. So that was 2 where you expanded it, and then 2 where you condensed it into 1. Okay. All righty. So once you're doing that, now we get to our final things, which are, kind of important. It's the actual solving equations. Okay. All right. Move on to the next. So this is actually from 5.1. Remember, we started in 5.1 and finished in 5.4, and they've grouped them all together. Okay, solving exponential equations, there's 2 kinds that you'll see. One of them is like this, where you can compare the bases, relate the bases. And then the other ones are when you can't get the same bases. Okay, that's when you have to take the log of both sides. This one, if you can get the same bases, let's see. Okay, we know that 25 is 5 squared, right? And we have 1/5. Well, we want to bring this up to the numerator, right? And you can do that. That's 5 to the 1. If you bring it up to the top, that would be 5 to the -1. So you don't want 1/5. You want 5. But you have the same bases. Okay, so remember, when you have a power to a power, you just multiply. So that would be 5 to the 2x. And this would be 5 to the -1 times the whole thing. So you have to distribute that -1 through. Let me draw it up here. 5 to the 2x equals plus 3. -1x plus 3. And then since it's just kind of fun to use this. It's the 5 equal 5. Then you can assume it's like dropping them. Just, oops, that's a pretty color, but let me go back to black. Okay, 2x equals, and then you solve a basic equation, right? Add x to the other side, you get 3x. Divide out, you get x equals 1. All right, x equals 1. Okay, relating the bases. All right. Okay, I'm gonna go to the next. I hope I'm not writing too fast. So this is another relate the base. Okay, 16 to the x. That's 16 is 4 squared. Right? 64 is actually 16 times 4. That is 4 cubed. Right? So we can rewrite it 4 to the 2x. It's a nice kind of short one. So since 4 equals 4, we can just set those exponents equal to each other and solve something nice and basic. X equals 3 halves. And there you go. So it just it's good if you can do that, right? So try to do that. If you can relate the bases, relate the bases. Okay. All right. So those were the two exponentials that way. I think the order of this assignment, I kind of wish they'd throw the next exponential in, but they do at the very end. Okay. So this is the one where you get the same bases. Now we're going to do a few problems with logs. Okay. And then we'll finish up with the other exponentials. Just kind of the order. Okay, so we get to the logs. The good thing is on this test, you won't see anything too complicated. There's two kind of logs that you'll see. This is the first one. This is when you have log equal log. Both sides have logs, right? Most of them aren't this way. Usually it's log equals like a number, but this is log equal log. When it's set up this way, you can just drop those logs and set the terms equal. Kind of nice, just drop, but that's only when both of them are logs. And then you solve there, let's see, that subtract x would give me 2x. And then add 5, 7. X equals 7 halves. So it's real basic linear equation. That's when you have log equal log. Okay, that's the first kind that you could see. And then the second kind is one we've already kind of done before. What happens when you have a log equal a number? Okay, the whole goal in an equation, you have to drop the log. Somehow you have got to get rid of the log to solve it. And we did. We dropped the logs here. And the next one, see, you have log base 3 equals 2. You don't have log equal log. And that's base 3. All right, so that's the difference. There's no log on the right side. If that's the case, you still have to drop the log, but you have to convert to exponential, which means you start with your 3. 3 to the 2 equals 5x minus 4. Right? You do your little circle. 3 to the 2 is 5x minus 4. And then you've got something very simple, easy to solve. Just convert to exponential first. So I hope you compare the two right in a row. The last one is when you had log base 3 equals log base 3. This one's log base 3 equals 2. Okay, and you have to convert. That would give you, let's see, let's add 4 to both sides and divide out by 5. We get 13 over 5. So not too bad. Not too bad. Compares the two, hopefully so. Right in a row, two different ones. Just kind of get it in your head which ones are which. All right, just two more problems, okay? Now we're finishing up with the other exponential. These are the exponentials when you clearly can't get the same base, right? Because 9 is 3. Let's see, if you think about it, you don't have to do this, but like 9 is 3 squared. Okay, you cannot get the same base, right? Not at all. All right. So, can't do that. So what you do, that's when you take the log of both sides. And here they don't specify which one. You're welcome to do either. I'm going to take the natural log of both sides. You're welcome to do the LOG if you want to. That's perfectly fine. You just have to stick with the same one. I do natural log. Once you do that, this X comes down in front and you get X. One last step. Remember, natural log of 9 is just a number. It's a decimal. You can divide out both sides. And those cross out. So X equals this. And that's all they're going to ask for. They're not going to ask for the decimal because we don't have calculators to do that. Obviously, in all caps, no decimals, right? So you can stop there. That's all you need to log in or type in. Okay, natural logs of both sides. Just make sure it's natural log divided by natural log. Okay, and last one is this one. Let's see. It kind of works the same way. It's just, the 3 in front of it, I'm going to choose to get rid of that by dividing it first and just rewrite it like this. And now, E is just a number. So you want to take the log of both sides, but you want to choose natural log. Okay. Hold on. Let me do this. Let me rewrite it. Natural log of e to the x equals natural log. Give myself some room. Here we go. Okay, I chose natural log because remember, natural log has an understood base e, and the shortcut says natural log of e, so the same bases, they simplify and they're just equal to x. Okay, you can cross it out. So x equals, okay, and there's your answer. All right. Okay, so those are the ones I chose. I skipped a few. Like I said, I know I got to look back over it. I know there were 2 synthetic divisions and 2 long divisions, and I only worked 1. So that's 2 of those, and I can't remember the other one that I didn't work. But it's all very similar. It doesn't mean you don't need to look at those. But if I were going to study for y'all for the test, be able to work these problems, okay? I also, if you go to your folder, like on Blackboard, your tests, a week 9 folder, I also posted a video of me working out the review assignment, but it's different problems. So you could also open that one, see if you could work it, and then, fast forward through the video to see if you got the right answer. So that's another way that you could practice, just to give you a different set of problems. And I really think that if you can do this, you should do great on your test. Okay, are there any, I can look at, are there any questions at all you can think of? You can use your notes. Make sure you use the Proctorio, but I'm going to be around, as always, in and out, but I'll try to be checking my emails even more than normal since it's test week. So if you have any questions, please just send me an email. And also remember, if, I'm going up to campus today at noon, and I'm there from noon to 2, and we're just working on the Blackboard. So you're welcome to come up there too. If not, that kind of finishes for me. And if y'all don't have any questions, then I guess I will see y'all later. Okay?
Thank you, Ms. Mason.
All good? Bye-bye.